Good morning everyone. Another nice rainy day in Devon. Right, so today I'm going to be back working on the big TDL speakers. It's been a while since I did the part one. I've looked at a few things on these in the last 3 or 4 weeks. It's been quite a while. I've just been so stacked out with other work, and these aren't the sort of speaker that I want to just do a little bit on and then leave. I kind of wanted to catch up with most of my other stuff, so I could then devote 2 or 3 days to working on these and getting them sorted. So since part one, I have been scouring the universe for either replacement original woofers which are no longer available. If I couldn't get those, the other thing was to get replacement suspension for them, because this has gone really hard and it's all cracking and breaking up, and that's the source of the inconsistency between these two speakers, which was one of the main issues, and also just the rough frequency response they had in the really low bass region. These are fitted to the 2 side transmission lines, and they really don't play much above 200 hertz, so they're basically a subwoofer, and then the remaining body of the sound is coming from our array here, so super tweeter, tweeter, mid bass drivers in their own transmission line. So if you kind of look at it, that this is your speaker and you've got a pair of subs each side, that's how I would sort of look at it. So yeah, I scoured the universe for replacement drivers, replacement rubbers. The good old internet community stepped up with information on these. Whilst TDL designed them, I think ELAC built them for them. Yeah, something like that. I don't tend to really get involved in the history of it all. It's to me a pair of drivers that don't work properly. So yeah, let's say can't get rubbers, can't get replacement drivers. I've got to rule them out. There's just nothing we can do, and the fact that we need 4 of them, 2 of them being 8 ohm, 2 of them being 16 ohm, connected in parallel in this crossover. So I don't fully understand the reason why they did that. It kind of gives a nominal 5 ohms that the low pass filter sees. Why they couldn't use 2 8 ohm drivers for a nominal 4 ohm load. I guess it keeps the components in the low pass filter slightly smaller, so there's a cost implication to that, but otherwise it doesn't really make much sense. So these drivers are modelled on KEF's B139. I went through my stock shelves, which are over there, and I have a good pair of these, and that's good because this is our only option. These are our only option, and thankfully Mr. Jerry and his pacemakers at Falcon Acoustics make these new. I did contact Jerry about whether I could purchase the suspension from him to fit to those, because it's largely the same shape, but apparently him and his bods had actually experimented with this, and as you can see, the cone, which is polystyrene on the B139, doesn't have the mass that this one does, and by all accounts it just wobbled around on there. So whilst you could probably make it physically fit, it wasn't going to do any good. So I probably mentioned in part one, the chassis of this is identical to this, the front. So if I offer this up, that goes straight in there, absolutely no problem at all. So TDL were, when they were IMF, or before they split from IMF, using KEF drivers, and obviously they modelled theirs on these, knowing these really well. So these are going to go straight in. They're a bit shallower, and I would say the motor on these is a bit more powerful than those. So this may be a good thing to be doing. So they're going to go in there nicely. And like I say, we can buy 4 of these new from Falcon, but I need to get them integrated and working properly. So what I'm going to do, thankfully these are bi-wireable. There's 2 sets of binding posts on the bottom. One set is purely for our subwoofers. The other set is for our mid-bass drivers, tweeter and super tweeter. So what I can do is leave this crossover in there, but connect the 2 woofers directly to the subwoofer binding posts at the back. So that means I can power these through the crossover, power these directly from the binding post with no crossover. What I'll then do is take the crossover out the other speaker and purely use the subsection on that to drive these, and I can measure and modify that as needed to integrate those. Something's telling me they shouldn't be too difficult to integrate. We'll just have to see, but that's the plan. So I'll bring you in closer to have a look at this crossover. Right, so there's our crossover in this one, which I'm going to leave in place, but we have a large red cable here and a large black cable here. They're the inputs from the binding posts at the bottom for the subwoofer. So I'm going to disconnect our 2 browns and our 2 blues and directly connect them to these. So that bypasses the low pass section of the crossover for the subs, and then leave the rest in place. And then I'll remove the crossover from the other one. So we have all of our wires here. So our 2 mid-bass drivers are paralleled, as are the 2 tweeters, and our super tweeters on its own. And then we will look at this crossover and see what we need to replace on there and what we don't. My client is very keen to keep these factory, so my instruction is to kind of get these as close to they were when they came out the factory. So there's going to be no silly upgrading or anything like that before anyone jumps on the comments. You should do this. Why haven't you radiused that? Why have you fitted electrolytics and not poly caps and blah blah blah? This is get them back to factory spec. I know we're bastardizing that with these new woofers, but that's the only part we're not in control of, really. So that's the plan, and I'm going to get cracking. Right, so I want to make sure that now I've separated these, the black and red are the feed coming up from the binding posts at the bottom. So this should be our negative in. Yep, and this should be our positive in. Yep. I'll just test between all the binding posts down the bottom, make sure we've got no connection between this and anything else. Nope. And then I'm going to short these to make sure that we've got a really low resistance between them. Perfect. So I'm going to connect those temporarily to our woofer cables, and then that's going to allow me to do a network for the woofers outside of the cabinets. They're not as heavy as I thought. I can pick them up. Yeah, that looks a bit creepy. That looks like a coffin. So while one of them is down like this, it's quite interesting to have a look around them, because obviously I need to tidy these up cosmetically as well. They're built from MDF, and in a few places the MDF, especially at the bottom, has kind of been dented, which kind of puffs it up, and on this one there's a little bit down there which has puffed up and it's like oils on it or water. So yeah, I'm going to get them as good as I can. So the whole thing is MDF, and then here we've got this beading running around, which is edge banded. We've got a few chips in there, so I'm going to obviously sand that up and re-oil it, and then repaint these black, so a satin finish. And then the tops, this is the worst one because it's got water staining on it. It's flatten that back as well, and the edge banding, and oil that up as well. The backs need a bit of filling and sanding. They're covered in cobwebs as well, so they've obviously been stored for quite a while. So yeah, let's get these woofers in. Perfecto. Right, so both of the B139s are in there. Interestingly, all the screws line up perfectly. The woofers fit in, except for one. It's not far out. It's not far out. It will just be a case of slightly opening up that hole. It might just be the woofers that I've got. But yeah, no issue. Otherwise, they pretty much drop straight in. So now I need to do a load of setting up in this room, which is big, and measure. I have a kind of near field method for measuring the base, near field and far field combination. So I should be able to get this pretty good, even though I'm in a room, and dial that room out. So I'm hoping largely we're going to be crossover wise as the initial design was, or original design was. But we'll just have to see. So I have taken out the other crossover. I can't remember where I've put it, but it might be best that we go through that before I start doing this. Right, so I've gone through this crossover and I have what I think is original literature, and I also have paperwork with values on it, but the values, this seems to be like from an email, not an original document like this. I mean, I'm assuming this is original, but having looked at the crossover design here and what's on this board, it's different by quite a bit in some places. So I'm going to try and go through this, and there's probably a few things I'll correct as I go through, because it's fairly complex and it was quite difficult to kind of read the traces on this, because you've got the woofer circuit over here, which you'd expect as you've got the input positive and negative, output positive and negative for the woofer section, but also components over here for the mid-range, and it's all over the map, and as you can see it's quite tricky to follow. So I'm not going to say at the moment that this is 100% accurate, but if we look at the woofer circuit first, which really is the one I'm concerned with, because the rest of it seems to largely be doing what it should, and we're not really mucking around with that. So if we look at the woofer circuit, we have our positive, we have our negative, we come in through a big 8 millihenry inductor. Again, I'm reading the values off of a sheet. I will measure these. And then we have one woofer, two woofers in parallel to ground. And then we're grounding this inductor with a pretty large 100 microfarad capacitor. And also across the supply we have a 10 microfarad capacitor, and we have a 47 ohm resistor. So whether that's serving as a Zobel filter or a notch filter of some description, I don't know yet. We will see. So that's our woofer circuit. Pretty simple second order really. So that's the circuit I'm going to be mucking around with to get the woofers integrated. Obviously what I don't want to do is muck around with the rest of the circuit. All my changes are going to be done in the woofer circuit. Right, now it's going to get quite difficult to follow probably. So what I'm going to do, I'm going to get my super tweeter circuit out the way first, because that's a really simple first order. So we have our super tweeter. In the document it says that this is a 1 microfarad, but it's not on this crossover. It's a 0.47 little film cap, and that's the sort of value you'd expect for something playing up as high as that super tweeter does. I mentioned in part 1 that this being a first order seems a bit lame to me, but there you go. Right, if we next look at the two tweeters, because this is fairly straightforward. So we come into a 4.7 microfarad cap, and then we come into a 2.2 poly cap and a 10 electrolytic. So in effect we're making a 12 there, using a poly to parallel up or bypass the 10. It's kind of a cheat's way of making a 12 behave as well as a poly would. and then we come out of that through a 2.2 ohm resistor, and we have our 2 tweeters. God, this is a dreadful drawing. To ground. Then in between these capacitors here, we have a little 0.25 millihenry air core inductor. So again, I can't confirm that value yet. So yeah, kind of third order really, with a resistor here. Having it in this part of the circuit will attenuate these tweeters, but also there's a level of tuning that goes on with the third order. If you just wanted to attenuate the circuit, you'd probably have it up here. But anyway, right, the mid-range or mid-bass, this gets a bit more complicated, and I'm probably going to struggle to draw this on here. So first of all, we come in through a 30 microfarad capacitor, and this is electrolytic, and this is bypassed with a little 0.1 microfarad, so 100 nanofarads. So again, we're cheating that 30 into performing better. And then we ground this with a really large iron core inductor. According to the literature, that's 8 millihenry, and it physically looks the same as the one on the woofer circuit, so I'm not going to dispute that at the moment. So this section of the circuit, this second order section here, is limiting how low those mid-bass drivers play. And going by these values, I would say it's around the 300, 400 hertz when it's rolling off. Right, and then we come through an air core inductor, which according to the literature is 1.1 millihenry. So now we're beginning to roll the top of the mid-bass drivers off. We are grounding this with a 4.7 microfarad capacitor. We are also coming through here with a 15 ohm resistor. Out of that resistor, we have a further 4.7 microfarad capacitor. But on the output of this resistor, so we've slightly attenuated the circuit here, we come through another 15 ohm. We come through a pretty large iron core inductor, which according to this is 1.7 millihenry. And then we have our 2 mid-bass drivers. But also in between here, we have a 22 ohm resistor. So kind of an L-pad arrangement here to attenuate and control the impedance this network sees. So I think that's correct. I will go back through it and look again, and if not in part 3, go through it again. But yeah, pretty complex. I count on the woofer circuit 1 resistor, 2, 3, 4, 5, and that's what I see on the crossover as well. 1, 2, 3, 4, 5. On the original document there's only 3, so I don't know why there's that difference. It doesn't really matter, but yeah, there's quite a bit going on there. So probably when it comes to recapping this, I'm not worried about things like this really massive 8 millihenry inductor being iron core. It's huge, and it's a laminated core as well, so I'm not particularly worried. A 30 microfarad electrolytic here, changing that for a polypropylene would be expensive, so remember I've been asked to put these back to factory, so I'll probably be replacing that with an electrolytic, bypassing it with a really good polypropylene capacitor. Air core inductor there, so that's fine. An electrolytic to ground, so I'll be replacing that. It's in shunt, not in the critical signal path. I would like to replace these 15 ohm resistors, which are in the critical path, with something decent, not these sandcast wire wound. 4.7 to ground, again, not worried about that being an electrolytic. Same with this 22 ohm resistor. It would be nice to change this 1.7 millihenry inductor with an air core, but I don't think we're here to do that. Similar thing with the super tweeter circuit, change that for a polypropylene. This will be polypropylene. I would be inclined to change these two just for 112, and again this 2.2 ohm resistor, something decent. So yeah, there we go, quite a bit to go through there. Aliens keep parking their UFO on the field over there. I have to keep seeing them off. Nightmare. Right, 4 hours of measuring and crossover modifications, and I am super pleased with how these have integrated. They've worked really, really well. And not a huge amount on the woofer circuit to adjust either. So what I'll do is, excuse me, is go through the measurements I now have. So this space is pretty big. It's about 6.5 meters by 6, and it's really tall, getting on for 3.5, 4 meters tall in the peak. So I can look at the impulse response when I'm doing the measurements and see where my first reflection is, and I can pretty accurately measure down to about 100 hertz in here. Probably 150 is accurate without gating, but I've kept it at 100 hertz. Really below that I can't do anything. The transmission line has been tuned, these woofers fit in there. I'm not going to do anything with a crossover below 100 hertz. It's just not what you do, and the room is going to have so much of an effect on basically everything from probably 300 hertz down anyway. So but yeah, these have turned out really well. So this is the new on-axis measurement I have using these two woofers. And as you can see, from 100 hertz all the way up to 20 kilohertz, we are plus minus 1.5 dB. So we're in that 3 dB band all the way along, which is incredible. This is the on-axis with the roll-offs for the woofer and the roll-off for this top end, so you can see where the crossover point is. And as you can see, it's about 250 hertz, something like that. So these really are subs. Had to play around with the shunt capacitors quite a lot on the second order low pass to get that roll off lower, because what I didn't really want to do is start mucking around with the inductor that was on there and creating a new low pass. I would have done if I had to, but I really wanted to work with what was there. And the Zobel filter, I think it probably is. I'll have to impedance test this and see if that's what it was there for. Makes no difference sonically whether it's in circuit or not, so I've taken that out. This is the on-axis phase relationship between the drivers, and this kind of tells us where the crossover points are. So as you can see from that, acoustically it looks like the crossover point between the woofers and the mid woofers is around 500 hertz. Between the tweeters and the mid bass drivers is around 3.5 kilohertz, which is what's spec'd on the information I've got, and around 13 kilohertz to the super tweeter. So yeah, it's all adding up really. Horizontally, if you watched part 1, you would have seen that really it's important that you stay with your ears on super tweeter axis. If you go above and below that, the comb filtering effect really kicks in and you get quite a dip in the response. So from a vertical point of view, super tweeter axis is the listening axis. Horizontally, much better. I played around with the low pass filter quite a lot, because as I was going off axis horizontal, I was creating a bit of a peak between these drivers and the woofers, so I needed to pull these back a little bit to kind of reduce that, and it's really good. You can get probably 30 degrees horizontally off axis and they are still really good. So here's the horizontal measurements. So yeah, I'm really pleased with those, even going as far as 45 degrees from 100 Hertz to 20 kilohertz. We've got nothing crazy going on really. We do develop a little bit of a peak at around 250 Hertz horizontally, but that only really causes us a problem, and it's not going to be a huge problem, if anything, when you're like 45 degrees off axis. And yeah, I can't see you really listening to them like that. So I think horizontally our listening window has probably improved, and the spectral decay is really nice and clean. So yeah, super pleased how these have just dropped in. I would say fairly minor crossover modifications, considering it's a speaker with what, 7 drivers. Their performance off axis is pretty good, not vertically, but these have been a win. So yeah, it's really good. I probably mentioned in the first video that I thought these were in their own airspaces. They're not. They do work in one chamber. The front transmission line is isolated from this, but as you can see, they're working in the same airspace. So yeah, right. Sonically, mega happy with them. I've got to fix this tweeter. So I'm going to take all the drivers out of both of them. I will, whilst they're all out, DATS test them all. I need to get onto Falcon Acoustics and see if Jerry can do me a deal on 4 new B139s, because that's not going to be cheap. And then it's get the cabinets cleaned, repaint these black, repair the backs, repaint those, and then sand and oil our veneered sections and recloth the covers as well. So that'll be in part 3. Right, well pleased.